Hello, and welcome to Graphic Linear Inequalities. My name's Tuesday Johnson. Here's an introduction to concept. Yeah, did it again. Alright, so inequality types and symbols. Sometimes inequalities are unbalanced, and these are called strict inequalities, so there's no equals at all. A less than B means that A is strictly less than B, so less than, lighter than, also left of on a number line. A is greater than B means that A is strictly greater than B. Less than, it always points at the small one. Less than also makes kind of a L that's kind of laying on its side. Greater than is opposite. Other inequalities that are not strict might be balanced. So we could have equality. So A, and then this symbol means less than or equal to B. So it's less than. Could be a situation like this, or it could be that they're balanced or equal to B. And A is greater than or equal to B means that A is greater than or possibly equal to B. All right, so what can we do with these inequalities? First, we have the additive property. And even though we call it the additive property, we can add or subtract. Because if X is less than or equal to Y, then if I add any constant C to both sides, X plus C will be less than or equal to Y plus C. We have a multiplicative property for a constant C. If C is greater than 0, then X less than or equal to Y implies that XC is less than or equal to YC. So this C could be a 1/2, right? So then we're dividing by 2. Are we multiplying by 1/2 or dividing by 2? Just like the additive property takes care of addition and subtraction, the multiplicative property takes care of multiplication and division. We just have to separate it. To positive constants, the inequality stays the same. The only time we have a negative constant, or the only time we switch directions of inequalities, sorry, that's what I was trying to say, is when we have a negative quantity that we're multiplying by. Okay, so if it's a negative quantity, it changes the direction of the inequality, and this is because of the way the number line's set up. Like the 3 is less than 4, but negative 3 is greater than negative 4. If we reverse an inequality, if I have a less than or equal to, then I could switch it around and make it y is greater than or equal to, as long as it still points at the same variable. Here it's pointing at x, and it's open to y, so it's all good. Keep in mind that these rules apply for all pairs of symbols. If I change this to a greater than, then this stays a greater than. If I change any of these to start with, the same symbol carries throughout, right? So the symbols work the same. We just don't do 4 definitions to use each symbol to say the same thing. All right, linear inequalities. We got to keep in mind that not equals to is also an inequality. An inequality of the variable x is the statement that one expression involving x is less than or equal to, or greater than or equal to, another. Right? So this less than symbol that I'm using, we could use any of the standard 4 inequality symbols other than the not equals. Although the not equals is also true, we just don't really think of it in this format as an inequality. An inequality in 2 variables, x and y, is an expression of the form ax plus by is less than or equal to c. But I said this was going to be linear inequalities. I could keep going. We could keep adding variables, but the main part for linear is that a linear inequality, in terms of more variables, all the variables will only have an exponent of 1. We'll never see a squared on an exponent. Maybe we'll see a 49 as a coefficient. Maybe we will want to write that as 7 squared. But our variables will never have exponents other than a 1, the assumed 1, when we're talking about linear inequalities. All right, so how do we graph linear inequalities in 2 variables? To graph ax plus by is less than c, or any of the other equality forms, what we'll do is we'll sketch a line that ax plus by equals c. Wow, really? I can't even read my own typing? That's sad. Sketch the line ax plus by equals c using a dashed line for a strict inequality and a solid line for a standard inequality. So let's suppose that I'm good. I'm not good. I didn't choose the pen. There we go. So we're graphing. I see a less than, so when I graph my line, I'm going to use a dotted line for ax plus by equals c. So I'll use a dotted line for a strict inequality and a solid line, which is in the next example, for a standard inequality. So then we'll choose a test point that's not on the line. My favorite test point is always 0, 0. 0, 0 is easy to substitute. The only problem is if your line happens to go through 0, 0. If the test point satisfies the inequality, the solutions is a line plus the entire region where the test point is shaded. If the test point is not true, then you would shade opposite of the test point, and this is our barrier line to determine. Alright, so if the test point does not satisfy the inequality, the set of solutions is the line plus the entire region on the opposite side. So this is if it satisfies, and this is if it doesn't. And that's based on choosing the origin as my test point whenever I can. Let's look at an actual example with numbers. Sketch the region. 4x minus y is less than or equal to 12. First, we'll sketch the related equation. You can see that we can subtract 4x from both sides. Minus y is less than or equal to 12 minus 4x. That's a 4. But we're solving an equation, so where's my eraser? There we go. So we're solving an equation, so let's not even worry about that right now. Take the y to the other side, subtract 12. We'll see we get y equals 4x minus 12. Now we sketch, we use a test point. And I'm going to put the test point, the TP, at 0, 0. And I'm going to ask myself, is 4 times 0 minus y? Oh my goodness, I did it again. Why can't I write and talk at the same time? 4 times 0 minus 0, is that less than or equal to 12? Well, yes, 0 is less than or equal to 12. So the toilet paper, the test point, the TP right here, it's all in the right spot, so we'll shade towards that side. All right, and your Desmos, for all your graphing needs, Desmos has the shading capabilities as well. All right, linear inequalities. Essentially, we graph the line, we make it dotted if this is a strict inequality. We make it solid if it is not. We use a test point, TP. If that test point works out, we shade towards it. If the test point did not work out, we would have shaded on the other side. Thank you so much for watching. Be sure to subscribe to Math with Tuesday on YouTube in case you take any future classes. Thank you for watching.